Okay, we are going to be going through 6 systems of linear inequalities on MathXL. Number 1 is asking you to graph the system of inequalities. We first need to see if both inequalities are solved for y. The first one is solved for y. The second one isn't, so we have to solve it for y. Okay, so we have 3y minus x is less than or equal to 12. So we first need to add x to both sides to get the y or 3y by itself. Then we have 3y is less than or equal to x plus 12. We then divide everything by 3 and we get y is less than or equal to 1 over 3x plus 4. So now we can graph both inequalities. Let's start with the first one. So we have y is greater than 3x minus 3. So we need to start at our y-intercept, which is negative 3. So there's negative 3. My slope is 3, so I need to go up 3 to the right 1. Then I'm going to keep doing that until I get to the top. Now I'm going to reverse it and go down 3 from negative 3 and to the left 1. And do that a couple times to finish up the page. Now I'm going to graph it. Now notice how there is no line underneath the inequality. That means you will have to use a dashed line because it is not equal to any of the points on the line. So we got to use a dashed line. And now look at the inequality. It is a greater than, which means we shade above the line. So everything above the line here, we will shade. Okay? Now we're going to graph the second inequality. That was the y is less than or equal to 1 over 3x plus 4. So we are going to start now at my y-intercept, which is 4, and I'm going to go up 1 to the right 3 and up 1 to the right 3 a couple times. Then I'm going to start back at the 4 and go down 3 to the left, or down 1 to the left 3, and then down 1 to the left 3 till we get to the other side. And then since there is a line under the inequality, I'm going to put a solid line. Okay, now notice how it's a less than inequality. That means we shade below the line. So I'm going to shade everything below the line. Now notice how this part here turns green. That is my overlapping part. That is the solution to the inequality. Okay, so I'm going to graph number 1 on MathXL. So I'm going to click to enlarge the graph. And now my first inequality that's solved for is y is greater than 3x minus 3. So I'm going to start at the negative 3 and go up 3 over 1. Now, notice how there is no line under the inequality. That means I'm going to make the line dashed. Okay? Now, my second inequality will be a solid line, and I will be starting at 4, because remember the equation is y is less than or equal to 1 over 3x plus 4 when we solved it. So I start at 4, and I go up 1 over 1, 2, and 3. Okay, and remember we noticed that my shaded portion here is this green portion here. So I'm going to go back and I'm going to shade just that portion. Okay, so you only shade that portion. Click Save, check Answer, and we got it. So that is number 1 on MathXL. Okay, so we are going to be going through number 2. Number 2 is a word problem, and it is telling you that cherries cost $4 a pound and grapes cost $1.50 a pound. You could spend no more than $9 on fruit, but you need at least 4 pounds in all. We got to create a graph showing the amount of each fruit we can buy. So first we got to set up our inequalities, so let's do that. So we have cherries costing $4 and grapes costing $1.50 a pound. So let's set up our variables. Let's let x represent the number of pounds of cherries we buy and y represent the number of pounds of grapes we buy. Okay, we could spend no more than $9 on fruit. No more than means I could spend $9 or less than $9, but I can't spend more than $9. So that tells me my inequality will be less than or equal to. So now I multiply $4 times the amount of cherries, so that's 4x. I multiply $1.50 times the amount of grapes, and that's y. Adding them up gives me the less than or equal to 9. So again, 4 times the amount of cherries plus $1.50 times the amount of grapes is less than or equal to $9. Okay. For my second inequality, we're told that we need 4 pounds in all. So the amount of cherries plus the amount of grapes will have to be at least 4 pounds. At least means that amount or more, so greater than or equal to. So all we have is x plus y, the amount of each that we buy, being greater than or equal to 4. So those are both of our inequalities, and now we got to solve them both for y so we can graph them. So let's graph the first one. Well, let's solve for the first one first. So to solve for y, I need to subtract 4x on both sides. That will give me 1.5y is less than or equal to negative 4x plus 9. I will then divide everything by 1.5, which gives me y is less than or equal to negative 8 over 3x plus 6. And that will be the first one I can graph. But let's solve the second one so we have it done. So we have x plus y is greater than or equal to 4. I would subtract x on both sides, and I'll have y is greater than or equal to negative x plus 4. Okay? So now let's graph these. Okay, so I'm going to now graph both of those inequalities. The first one was y is less than or equal to negative 8 over 3x plus 6. So I'm going to start at 6, and since it's a negative 8 over 3, I'm going to go down 8 to the right 3 and do it a second time. Then, since there is a line under it, it will be a solid line, so I'm going to connect them with the solid line. Okay. Also, since it is a less than, I will shade below the line. So everything below the line here, I will shade. Okay. So now I'm going to graph my second inequality, which is y is greater than or equal to negative x plus 4. So my y-intercept is 4, so I start at 4. Negative x means I go down 1 to the right 1. And I will keep doing that in both directions, but going to the left, I will go up 1 to the left 1. Okay, so then I will connect them with a solid line because there is a line under it. But since it is a greater than, I will shade in everything above that line. Okay, so that means the green overlapping part here would be my solution. So now let's put that on MathXL. Okay, so now I'm going to graph both of my inequalities. Now the first one's going to be a little trickier to graph. So first I'm going to graph my y-intercept, okay, which will be a solid line because it is a less than or equal to. So I will start at 6 for my first one. Now for my second one, I cannot go down 8 and over 3. So I'm going to have to use my y equals function on the calculator to find another graph. So if I go to y equals, type in my equation, I will see that one of my points on this one would be 1.5 and 2. So I go to 1.5 and 2. So again, just use your y equals function, go to second graph, and then use your table to help you find another point to use. Okay, so then my second inequality, I will start at 4. It's a solid line still, but it's equal to, and go down 1 over 1. Okay. Now remember, look at our shading. We shade up here. So I'm going to put the paint bucket there. Then let's see what we get. We only shade it at the overlapping part. And there we go. That is number 2. Okay, let's look at number 3. It is asking you to determine whether the ordered pair is a solution of the given system. We are given a point of 315, and we're giving 2 inequalities. The first one is y is greater than 2x plus 3. The second one is y is less than 4x plus 1. So what we're going to need to do is substitute that point in for both inequalities and see if we get true statements. So starting with the first one, I will substitute in 15 for y and 3 for x, for y is greater than 2x plus 3. Now we have 2 times 3, which is 6. So 15 greater than 6 plus 3. 6 plus 3 is 9. So is 15 greater than 9? Yes, it is. So it works for the first one. But we can't make a definitive statement until we check the second one. So now the second one is y is less than 4x plus 1. Substitute in 15 for y and 3 for x. 4 times 3 is 12. 12 plus 1 is 13. This is saying 15 is less than 13, and that is definitely not true, so it is not a solution. Okay, so it is not true, so we'll say not a solution for number 3.